Hello friends, welcome to the course Essentials of Data Science with R Software 1, in which we are going to handle the topics of probability theory and statistical inference. So you can recall that in the last couple of lectures we have learned the very basic operations of the R software, like as addition, multiplication and other types of operations on a scalar or a vector and so on. Now in this lecture and in the next lecture I will try to take up some more topics of the R software which I am going to use in the forthcoming lectures. So in this lecture I am going to take up the topic of built-in commands and simply a plot command. You know that R has a wonderful capability for creating beautiful graphics and very informative graphics, and it depends actually on you that what type of graphics do you think is going to convey the hidden information inside the data. That will be your choice, that will be your decision. But in this course, just to make the things very simple, I am just going to use here one type of simple plot. So in this lecture, very quickly I will try to discuss that how are we going to use the built-in commands and how are we going to use the plot command to create some simple graphics. Well, I know that you or say most of you have done these things in the R software, but it is important for us to have a quick review. So definitely I will not be going into much detail, but I will very quickly brush up the knowledge. So let us begin our lecture. So you see, in R software we have two options, that either I can write a command on the R console and execute the program, or there are some built-in commands which are available or which have been programmed by some other people. So those commands are readily available inside the R software to compute different types of mathematical function. For example, if you want to multiply or if you want to sum, you want to find out the arithmetic mean, etc. So my objective here is very simple, that I want to show you that how are you going to use them and how you have to be careful while using those operations. For example, let me try to take here a couple of examples to illustrate that how are we going to handle it and how you have to be careful. Well, there is a long list of the such functions, but definitely it is not possible to take up all the commands which are available inside the R software, but I am sure that if you try to learn these basic commands, after that there should not be any problem for you to understand those commands. Now let me try to take here one simple example. Suppose you want to find out the maximum value for a given data set, right? Suppose I have two options here. The first option is this, those people who are good in programming, they can write a complete program for find out the maximum values. But those who are not good in programming, it is advised and preferable that you can or they can use the built-in function which can directly compute the maximum value out of a given data set. And similar is the justification for all other commands also. So in case if you want to find out the maximum of a given data set, then the command here is max. And the rule here is that you have to write down the values inside the parenthesis. So if you write here max and inside the parenthesis, if you try to write down the values, then it will give you the maximum among the available values which are given inside the parenthesis. But now there is a question. In order to answer that question, first let me try to pose here two examples. You can see here I want to find out here the maximum of four values, 2.4, 7.3, minus 3.2 and 4. So you know that 7.3 is the maximum value, and if you try to operate it on the R console, it will try to give you the value here 7.3, and you can see here this is screenshot. But if you try to see here that in this example I have not used the C command. C command means when I am trying to give here the values 2.4, 7.3, minus 3.2 and 4, I am not using here the C command to combine these values, but I am simply writing down these values. Okay, now I try to do the same operation using the C command, and I try to write down the same values here, but I now use the C command and I try to write down here all the data values inside the parenthesis, but with the C command, and answer is once again 7.3. So, you can see here that now here in this case I have here two options, that I can input the data using the C command or without using the C command, and it is giving us the same answer. But that is the place where I would like to make you cautious. In this maximum command, it is happening that if you are trying to give these values with or without using the C command, both are working. But that may not really be true with many other functions. Now, you can ask me why this is happening. One of the possible reasons I can think is that because this R software was developed by a team, and when it started, different people all over the world, they started contributing in this R package. Somebody wrote the program for maximum, somebody wrote the program for sum, somebody wrote the program for variance, etc., etc. It might be possible that when they are trying to write down the program, then the person who has written the program for finding out the maximum, he has written the program in which the data has to be given without the C command. But in case if somebody is writing a program for finding out the sum, then that person may have written the program using the C command. That means the data has to be given with the C command. But later on, when people tried to work together, they started converging, then they tried to make such function at the same level. So, they also introduced that if you try to give the data using the C command in the maximum function, that will also work. So, now what is happening, that this C command is working on the maximum with both, with C and without C, but that may not happen always. I will try to show you. So, now what you have to do? My simple advice is that whenever you are trying to give a set of data in the format of a data vector, always use the C command. Just avoid all the confusion. Because what will happen, I will show you that in some functions, if you do not give the data in the format of C command, even then the output will be there. That output might be calculated in a very different way than what you want. Suppose you want to find out the sum of three numbers 1, 2 and 3, and if you simply write, say, sum within parenthesis 1, 2 and 3, possibly it may give you an answer only 1. That may not add 2 and 3. But if you try to use the command sum and within parenthesis you try to give the data in terms of C within parenthesis 1, 2, 3, then possibly it will give you the answer 6. So, now you can see what will be the consequence when you are trying to write down the bigger program in the data science. You want to compute a complicated issue, you want to compute it, and somewhere you are trying to use this function like sum or maximum. And if you not give the C command, it will not show you any type of mistake or error. The R will compute the thing, and R will not even inform you that there is any mistake or problem. And once you are trying to do such complicated calculations, at the end you will not be able to judge whether R has done the correct computations or not, because you have given the command correctly to sum, that is SUM. So, that is why in order to make the life simple and to avoid any type of problem in the programming, my very simple advice and sincere advice to you all is that whenever you are trying to use the built-in function, try to give the data using the C command. That is the safest. right. So, now let us come back to our slides and try to see some more operation. I will try to show you these operations on the R console also. Okay, so now similarly, if you try to want to find out the minimum of the given values, then just like this maximum, I have here the command min minimum, and inside the parenthesis you have to give the values, and it will try to give you the minimum value out of the values inside the parenthesis. And then minimum also I have the same issue. If you try to use the command C or don't use the command C to input the data, it will give you the correct value. Right. For example, you can see here that I am trying to find out the minimum of 2.4, 7.3, minus 3.2 and 4, and it is giving me the answer minus 3.2. But here I am not using the C command. But in case if you are trying to use the C command here, then the minimum of those values 2.4, 7.3, minus 3.2 and 4, this minimum is coming out to be minus 3.2, but here you are trying to use the C command. So, once again I will suggest you that do not get into this complication and simply try to use the C command when you are trying to enter the data. Now, similar to maximum, minimum, we have here different types of command. There is a long list, but I just want to give you a glimpse, and I am just trying to give you here a simple function which we expect that possibly we will be using them, or I expect that you will be using when you are trying to write down the program for your data science. That is your ultimate objective. That is why you are here. Okay, so now in case if you want to find out the absolute values, then there is a function here ABS, and inside the parenthesis you have to write down the data. As a rule, I will always say that just try to use the C command. Similarly, in case if you want to find out the square root, you have the command SQRT. Similarly, for finding out rounding up and down of the number, we have the command round, floor, ceiling. And similarly, to find out the sum and product, we have the sum and PROD commands. That will means if you try to write down the number inside the parenthesis, they will give you the sum or product of those number inside the parenthesis. Similarly, if you try to find out different types of log functions, we have the command here log, log10, log2, etc. And similarly, if you want to find out exponential function like e raised power of here x, then you have the command here exp. And similarly, if you want to find out here any trigonometric function, we have the built-in commands here sine, cos, tan. For cosec it is a sine, for sec it is a cos, and for cot it is a tan. And similarly, for the hyperbolic functions, we have the sin h, cos h, tan h, a sin h, a cos h, a tan h, and then there is a long list. Right. But instead of going through these commands, let me try to take here some example to show you that how they are going to work. And then what is the advantage of this built-in function when you are trying to work in the R software? That is my ultimate goal. So, suppose if I try to take a scalar and if I try to find out the square root, suppose I want to find out the square root of 9 like this. So, you can see here this is coming out to be simply here 3. And now I try to use the same SQRT command over a data vector. Suppose my data vector here is 25, 16, 9, 4. So, you will see here when this square root function is operating on the data vector, this will become like a square root of 25, square root of 16, square root of 9 and square root of 4. And you will get here an answer here 4532. And this is here the screenshot. So, you can see here that this built-in functions are also operating over the data vector, right. And similarly, if you want to find out here the sum and product function, suppose you want to find out the sum of a set of numbers. So, you simply try to give those numbers using the C commands and try to use the built-in command here sum, SUM. SUM will give you the sum of all the numbers which are written inside the parenthesis using the C command. And you will see here that if I try to write down here sum of C 5, 4, 3, 2, 1, this will give me the sum of 5 plus 4 plus 3 plus 2 plus 1, and this answer will come out to be here 15. And similarly, if you want to find out the product of the numbers, just try to give those number inside the parenthesis, just like sum, you use here PROD product function, and this will give you the output of 5 into 4 into 3 into 2 into 1, which is here 120. Right. So, before we try to go further, let me try to show you these things on the R console itself. Right. So, if I try to take here first the example of maximum. So, if you try to see here, if I try to take the maximum of 1, 2, 3, 4, this is giving me the 4. But if I try to give here the values here like as maximum of C1234, that is the same data set, but I am trying to give the values inside the parenthesis using the C command. So, this will give me the value here 4, right. So, you can see here it is not making any difference. And similarly, if you want to find out here the minimum, then instead of here max, you try to use the command here minimum. So, minimum of C1234 will be 1, that we know. And if you remove the C command from this minimum command, even then you will see the answer is coming out to be here 1, 2, 3, 4. Okay. Now, in case if you try to find out here the square root of say here some value here, say 16. You can see here that answer is 4. Well, I am trying to take an example where you know the answer, so that you can verify that whatever R is doing, that is convincing with what you know. And similarly, if I want to find out say here square root of here 16, 25 and 36. Suppose I do not give here the C operator. You can see here it is not working, right. It is not working. But if you try to give here these 3 values using the C command over here, then you will see that this is working, right. And similarly, if you try to use here the sum command, suppose if I want to sum here 1, 2 and 3 number 1, 2 and 3. So, I try to use the C command, and if I try to give here sum, it is giving me 1 plus 2 plus 3, which is 6. But in case if I try to remove here the C command, let us try to see what happens. It is again giving me the number here 6, right. And similarly, if you want to find out here the product, say product of here C 1, 2, 3. So, you can see here that we know 1 into 2 is 2, 2 into 3 is 6. So, the answer is coming out to 6, and you can see here whether what will happen if I do not use here the C command, that is still working, right. So, it may happen that in some cases C command is working, and in some cases the C command is not working. For example, you have seen here in this square root command here, this is not working. So, now let us try to consider here some more commands over here. Now, suppose I have a variable which is also in the form of a data vector, where the inputs are going to be in the form of a data vector. So, now you can see here that x is equal to here 3, 4, 5, 6, that is my data vector. And if I try to define here a new variable y, which is simply here x hat 2, that is x square. So, this also can be done. So, y will become here 9, 16, 25, 36. So, that means when we are trying to define the variables in terms of data vectors, that is also possible. That is what I am trying to show you here, right. And this is how the things will work without any problem. And similarly, if I try to show you here some more operations here, like as suppose if I want to find out here, see here log of some value here 100, you can see here this is not the log base 10, but this is log base e. And similarly, if you want to find out the exponential of here 100, you can see here this is coming out to be here 2.688, right. And similarly, if you want to find out here the absolute value of here -3, this will come out to be here 3. And if you want to find out here the absolute value of here some data vector here -2, -3, and you can see here this is again coming out to be 2, 3. And if you want to know that whether the C command will work in this command or not, you can see here this is not working, right. For example, I can show you here one thing. Suppose if I want to find out the arithmetic mean of the two values 1 and 2, then the command here is mean. And if I try to give here mean C1, 2, you can see here this will come out to be 1 plus 2 divided by 2, which is 1.5. Now, means I do not know whether the C command is needed here or not. So, I try to give here mean 1, 2. Now, you can see here this is going to give you only here the value 1. Do you think that mean of 1 and 2 is 1? No, the mean of 1 and 2 is 1.5. But what it is doing here, it is giving you an answer 1. That means it is trying to take only here the first value. This is exactly what I was trying to tell you in the beginning, that if you do not use the C command, for example, in the case of absolute, it is giving you an error, so you will come to know. But in the case of mean, this is not giving you the correct value, but it is giving you some value. This value is wrong, but when you are trying to execute this function inside a bigger program, then it will not be possible for you to check each and every step for such a big data set, and then it will be computing something, and you will never come to know that the value of mean has been computed as 1.5 or 1. Whatever is the outcome, that will be used as an input to another function. So, that is what I said, that in the beginning, that you have to be very careful when you are trying to use this built-in function. So, my ultimate message for using this built-in function is this: handle with care. They are very useful, but you have to be very careful when you are trying to use them. Okay. Now I try to come to another topic which we are going to use in our lecture. This is about the bivariate plots. You know about the plots, that plots will give you different type of display, and they also help us in retrieving a different type of information which is hidden inside the data values. And R has a wonderful capability to create very beautiful informative graphics. And believe me, when you are trying to really venture into the topics of data sciences or the subject data science, you have to be very good in exploring different type of this graphics. Graphics will play a very important role when you are trying to work in the data sciences, because many times the information which can be understood by a graphic, that is more difficult to explain by a formula or a words. For example, if I try to create here a smiley like this one, right, you can say that very clearly that this person looks to be happy, and if you try to write down this, the same thing, but if I try to write down here this face to be upward, instead of upward it is downward, it will show that the person is not happy. So, that is the advantage of using the graphics that you know very well. But instead of going through with all possible topics or all possible graphics, I am trying to take here only one plot, which is bivariate plot, which I have used in the further lectures, and rest depends on you, that how much you want to understand and learn the graphics in the R software. So, this bivariate plots, they provide the first hand visual information about the nature and degree of the relationship between the two variables. Right. Now, this relationship can be linear, or this relationship can be non-linear. Right, means if you try to plot here a data set, it may look like this, or if a data set is like this, it may look like this. Right. So, there are different types of ways by which you can determine whether the relationship is linear or non-linear. That we will try to learn when we are trying to understand the different topics of data sciences. But here I try to take here one particular type of plot, and I try to show you with the different types of example that how this is really going to work. So, I am going to talk about the bivariate scatter plot, in which I have here two dimensional graphics in the form of that we have here x axis, y axis, and then we have data here in the form of pairs, something like xi, yi, and then if we try to plot this data here xi and here yi, and then we try to plot these values, and then they will try to give us a two-dimensional plot. So, suppose if I have a data set in two data vectors, say x and y, which are given here like this, then the command here is plot plot x comma y inside the parenthesis, and after this there are different types of options which are available, and that can make the graphics as informative as you want. For example, one option here is to use the command here type. So, now in case if you try to use the type is equal to p, then the graphic will be in the form of points, which is actually the default. And if you try to use here the type is equal to L, then the graphic is in the form of line. And if you try to use here the type is equal to B, then you will have here points and line both. If you try to use here C, S type, then there will be a lines which are only the part L1 of only B, means out of this B only lines will be there. And if you try to use here the type is equal to O, then both points and lines, they are over plotted. And if you try to use here the type is equal to S, then you will have a graphic in the form of stair steps. And if you try to use here the type is equal to H, then the graphic is in the form of histogram or like high density vertical lines. So let me try to take here a simple example and try to show you. But before that, I just want to give you one information that, well, in this slide I am trying to give you some basic operation, but definitely there are many more operations which are possible with this plot command, and my request will be that you please try to look into the help menu to understand those commands. But some of the popular options which are needed to create such bivariate plot is, suppose you want to give the overall title of the plot, then I have to use here the command here main. In case if you want to have the subtitle for the plot, I have to use here the command here sub a. And similarly, if you want to have here the title on the x axis, then you have to use the command xlab a. And if you want to use the title on the y axis, then you have to give the command here ylab a. And if you want to control the aspect ratio, then you have to give the command here aspthe aspect, and then means and you have to give all these things over here, means inside the parenthesis separated by comma. Just try to write down these names and then you try to give this option. Similarly, you can also change the color by using the command col, etc. But once again, I will request you that you try to look into the help and try to see the help plot or say help type. That will give you more information. So now, in order to explain the use of these options with the plot command, let me try to take here a very simple example to explain you that how are we going to work. Suppose I take here simple example where we have collected the data on 20 students on their marks, and these marks have been given means out of 500 maximum marks. And you know that this that the marks of a student, they essentially depend that how many hours the student has studied. So that is our belief. So we have collected the paired observation on the number of hours of study of a student and the marks, right. So these 20 observations are written here under the two data vectors, say here marks and here hours. So if a student number 1 has studied 23 hours, then it is evident from this data that this is a 23 in the data vector hours. And then we have here 337 in the marks, that is the first element in the data vector marks. So this student who studied 23 hours has got 337 marks, and this is here like this. And similarly, the second student who has studied 25 hours and the student has got 316 marks. So it has been written to 25 comma 316 and so on, and this data has been stored exactly in the same way in these two data vectors. Now I try to use here the command plot. If you simply try to use here the command plot xy, by default it will give you the points. So I try to use here these two data vectors, and if I write plot hours marks, right, and you will get here this type of graphics. You can see here that this is here hours, this is here marks, and you can see here these are your here different data points. So this is indicating that as if there is a approximately linear relationship between the number of hours of study and marks. So that is giving you this type of information. And similarly, if you try to use here that type is equal to L, then what will happen? All these points which are here, they are joined together like this one and so on, and this is the output here. So here there are no points, but those points have been joined by lines, and that is why the type here is L, which means lines. And similarly, if you want to have here both points and lines both, then you have to give here the type is equal to here B. Actually, you can also write down here type is equal to, say within double quotes, try to write down here B. So B means both lines and points both are there. For example, you can see here these are my here points and these are my here lines and so on, right. Okay. So now we take one more option, that you can see here that here this lines and here points, they are separated. But if you want to join them together, then the option here is you try to use here type is equal to O. O means overplotted. That you can see here that there are points here, and these points are joined by the line, and these lines are going over the points, right. So, this option will give you this type of graphic. Okay. And then in case if you use here the type is equal to H, H means high density vertical lines or say histogram type of thing. So, all these points which are here, they have been dropped with a line on the x axis, and yes, different type of information. Well, we are going to use it, so you have to understand well how they are going to work and how they are going to interpret in the decision sciences, that we will try to discuss when we try to talk about the probability mass functions. Well, so I just told you this thing so that you should be confident enough that we are going to use these topics over there. And similarly, in case if you want to use here the type equal to S, then you will get here this is stair type of curve. You know what is the meaning of a stair steps. Do you know that stairs are like this, and if somebody walks over here, it can go to the roof or some height and so on. So, for that you have to use here the type is equal to small s, and this will give you this type of plot over here, right. So, now what I try to do here, that I try to use this data and I try to show you these things on the R console also, right. So, let me try to just copy this data to avoid or to save some time on this R console. So, you can see here this is my here marks, and then I try to save here the data on here hours. So, you can see here this is our hours data, and I try to create here some space so that I can show you the graphic very clearly as this happen. So, you can see here now this hours data is like this, right. And if you try to plot here, plot between say hours and say here marks, you can see here this graphic is created like as here, right. And similarly, if you try to change the type, for example, as I said that here the type is equal to, if you try to use it here point, well this is the default and you already have got the point. So, it will not make any change, right. I try to make this graph little bit smaller so that you can see both the things. Okay. Now, I try to change here this type. You can see here very clearly both the windows together. I try to make it here type is equal to L, that means line. You can see here that the same data has been plotted using the command L type plot. And similarly, if you want to have here points and line here both, you simply have to type here type is equal to B, that means both, and you can see here this graph is changed, and then you have here points and lines both. And similarly, but they are separated, but if you want to overplot them, just try to use the option type is equal to O, and you can see here this is the figure in which the points and lines, they are overplotted. And similarly, if you try to use here the option H, then you will get here a histogram type or say high density vertical lines, that you can see here from each of the point. Means you can see here if I try to show you here this thing, and if I try to show you here this thing, from the same point these lines will be dropped, you can see here, right. And similarly, if you want to have the plot of a steps type, so you have to use the type equal to S, and you can see here that this command is producing this type of graphic, right. So, now we come to an end to this lecture, and I have given you a basic idea, basic background about the plot command and the built-in functions. But definitely my idea was very simple. I just wanted to sensitize you that we are going to use some built-in functions and some graphics. Well, when we are trying to use the built-in function, definitely we are going to introduce many more built-in functions. But my idea of telling you this built-in function was that how to use those new functions. So, the moral of the story, what we have learned in the built-in function, that you have to just write down the function, and then you have to write down the data inside the parenthesis. But the rule what we are going to follow, that we are always going to write down the data using the C command. Otherwise, I do not want to make the life complicated or confusing. As simple as that. And similarly for the graphic also, well, I am going to use only these graphics because I will be working at a very basic fundamental level, but when you are trying to work in the decision sciences, the data size is very big, and this is only you who is going to take a call that which of the tool, whether this is analytical tool or graphical tool, has to be used. Your basic objective will be only that whatever is the hidden information inside the data, that you have to bring out. And for that, what you have to do, nobody will come from the sky to inform you. This is only you who has to think and who has to take a call. And that is how you will become a data scientist. Right. So, you think about this, try to have a quick revision of these commands, try to practice this, and I will see you in the next lecture with some more topics. Till then, goodbye.